Now we're recording every single time. Okay. All right, back over here. So we have dirt at this end, of course, and it becomes loose. And then we're using what's called an Archimedes screw to push it to the back of the tunnel boring machine. And then we need to, this will be 10 meters or 30 meters into a tunnel. And then we have to get the dirt that's being produced here all the way back out the tunnel. So we've discussed a couple of different things. One of which being small pods that come up to the back of the vehicle, pulled along sort of like a chain, like a cable car system or a ski lift that, take on a load of dirt that's stored by the tunneling machine and then carted back out of the tunnel, and they deposit the dirt out there, and then they come back to the boring machine. We've also talked about maybe an RC car system that is able to run up and down the tunnels, pulling the dirt out. And then the last idea that we had that's kind of stupid was using high pressure air to shoot or pump the dirt out of the tunnel.
I was going to say, what about a vacuum type, vacuum hose?
Yeah.
Like an air-water mixture could work.
Slurries.
Yeah, there's a little bit of concern about, that's a lot of complexity to add, and the ability for it to break. It's just when you add complexity, it just becomes much more likely that you're going to fail. So
I feel like vacuum might be less complex than like autonomous cars driving back and forth. But
I guess there could be an argument made for that. I'm initially skeptical of that, but once again, let's loop it a little bit back towards prototype stages. So in terms of cutting heads, let's talk a little bit about cutting heads. What are some ideas that you guys have? I'll pull this off screen for a sec to not bias people, but what are kind of the necessary features that you guys are recognizing?
If you give me a second, I'll pull up a picture of the one I was imagining.
Okay.
one thing I was considering is there has to be space kind of for the material to fall down before it gets sucked back in. So there has to be some space after the cutting head. The cutting head just can't be flat up against the surface, because there has to be room for the dirt to fall down and to be pulled out the bottom.
Yeah. Yep. I'll share my screen real quick. So I was imagining one of this, which is how traditional tunnel bores are, where it's just a flat radial surface and just pretty much saw blades just placed in strategic positions around it, and then the whole thing just rotates, and that will just cut up the dirt, and the dirt gets fed into it, which then goes an Archimedes screw out the other end.
Yeah, my one concern with that, so the reason I kind of steered away is that that's, I think, a big part of the limiting factor right now for current boring machines, is that kind of the amount of dirt cut away per rotation is pretty minimal.
The feed rate.
Yeah. So maybe it's a matter of increasing the tooth size.
I was looking at the calculations and equations. The more cutters you have increases the feed rate, not necessarily the tooth size, but if you just place more cutters, instead of 3 on each angle out here, more, and just have a ton more cutters, then you'll have a lot faster feed rate and you'll move through the dirt a lot faster.
Sure. I think it's going to depend a lot too on the type of soil or rock that we're going through, because Dan's design would work better on dirt, but if we're going through hard rock, we need something more aggressive.
Yeah, and that's definitely something that they've still not provided any details on, but they've said they want to add, or they'll provide more details on that in the coming weeks.
Yeah, it seems to me like what we're going to dig through is going to be a curated selection of materials. I imagine that means rocks, but I bet they're going to tell us that rocks are limited to a certain size. That's my initial impression. And it's also possible they say that they've got gigantic boulders that we'll have to navigate around with sonar. But in terms of a first-year competition, that seems pretty stupid to me. So we'll pretend like that's not a possibility for the moment. Let's see here. Quantity of blades. So the trade-off, what do you think the trade-off there is, though, Cody, for quantity of blades and feed rate?
I had the equations earlier. I found like just a full sheet of like boring related equations.
All right, so is that like a torque equation where you're?
Yeah, they're torque equations that take into account like they find like the cutting speed using like the diameter of your cutting like head, and then the amount of cutters you have on that cutting head, and some other things. So yeah, there's like share again real quick. Yeah, there's like the cutting speed equation, which takes into account the diameter and like some variable n. I don't remember what n was, but you use that cutting speed that you find to then find like the machine time, and then the feed rate, which is like actually how much dirt you're going to be pushing in and out of the machine, and that is used to find like your penetration rate and so on and so on, like how, and that pretty much just translates to how like fast you're moving through the dirt.
Okay, that's a good resource.
The one thing we should look into is, it looks like these are like for machining bores. And
yeah, these are for boring ones, like boring through metal and things like that, but it translates kind of similarly, I found.
Yeah, we should just make sure that the scale, because like I think boring a hole through metal, like boring a 2-inch hole through metal is one thing. I'd be curious to see how the assumptions that would go into that would scale when you're now boring a 20-inch hole or a 200-inch hole.
Yeah.
But I think that, yeah, this is a really good place to start the math off, that we can do our analysis with.
Yeah, it might be good. I don't know if you'd be interested in this, Cody, but trying to pick apart why it might be a bad way to do the math rather than its merits. I agree that that seems like a pretty good facsimile for trying to figure out the math for digging a hole. But it'd be good to have an analysis of why it would be a poor method. Do you understand what I'm saying?
Yeah. I read through a few like research articles on like tunnel boring and like real tunnel boring machines, and they seem to use like similar type of equations and similar like vocab, like feed rate and all that stuff. So I feel like they translate pretty well. I'm sure there's probably like differences in like the constants and things that you have to take into account, and like I'm sure the equations are probably a little bit more complex than the ones for just a simple drill, but I feel like they can be translated pretty well. I would need to like actually research and find like the real extra complex equations probably.
Okay. Yeah. Yeah, that sounds good. I'm going to make a new folder right now that's just going to be called resources. Can you pop that in a 2020 competition folder?
2021.
2021, rather, yeah. And then I'm going to I'm making a subfolder called cutting.
Cool.
Okay. So Charlie, you're in Denver, right? Esther, you're in Spain. So we're gonna have to figure out how to kind of accommodate people that won't be able to pick up parts. Do you guys either have sort of kind of a part of the project that you're kind of interested in? The way we're kind of seeing it right now is that there are 3 main aspects, and that's digging and processing the dirt, and then getting it out of the tunnel, and then navigating the boring machine. Of those three, does something kind of pop out that kind of interests you?
I would say the digging portion, but
Okay.
I guess as we move through the project, we're kind of going to go through all three of those steps. So
And I would say taking out the of the tunnel.
Getting it out of the tunnel.
Yeah.
and also Dan, like I'll be able to commute pretty easily to Boulder if
Okay.
doing anything in person. So
Do you have any classes up here?
they're all online, so not technically.
Digging, and then, man, we got to come up with a word for getting rid of the dirt.
Excavating.
Evacuating, extracting.
Yeah.
Yeah.
It's a lot of words that start with E.
There's a really simple word that I really want to use, but I'm not going to use it. So
I think it's fine to use. I think you're just pooping out the dirt and you're all good.
Just
You're good to
pooping it
go.
straight out. Yeah, that's what's happening.
Yep.
Okay. So then let's get some jobs for this coming week. So Charlie, are you able to take a crack at designing a digging head? So the goal is for this to be 3D printed, and just basically run 3D printing for as long as we can. And then when things start to break because we're getting too big, we'll have to figure out how to machine them. But for now, we're just kind of taking machining off the table.
Sure.
Cool. All right. So cutting head, and then you're able to do that by Monday.
Yeah, and we're gonna power it just by like a regular hand drill, an electric drill.
Yeah.
So it'll just chuck into basically the front of the drill. Okay.
So we'll have a 1/2-inch hex tube. So it's called churro tube if you look it up on AndyMark. I'm gonna send that to you on Slack after this.
Okay, I'm just gonna insert that kind of into a female part. Gotcha.
Cool. Esther, do you want to think about, so I've already mentioned kind of the ski pod idea, the RC car, and then like the pipe.
Mm-hmm.
You want to try to brainstorm a 4th or 5th idea of some sort
Sure.
over this weekend? And then if you can't think of anything else, because we were really running out of ideas, then maybe you can take a deep dive onto one of the other 3 ideas. But up to you.
Okay.
Okay, cool. And would you be able to offer an update on Monday with whatever you find?
If I find something, yeah.
Okay, yeah. Maybe just like, yeah, if you've got 5 minutes of something to talk about, that'd be great.
Mm-hmm. Okay.
All right. And then let's see here. Ahmed, you're busy with logistics. Cody, you're worried about some math.
Oh yeah, I can look more into that stuff, and I'll probably design a cutting head as well on my own.
Okay. Math and a cutting head.
I think Dan, just to I guess solidify or formalize that, obviously we don't have a design yet. The whole point of Dan's digging box is for us to build a bunch of different cutting heads and just like figure out how they work. Yeah, Cody, it sounds like you're interested in making a cutting head. Charlie's making a cutting head. I think when we get more people on the team, it doesn't hurt to have a couple more people still making cutting heads just to see what it all does.
Yep, totally. Cole, do you want to make a cutting head?
Potentially, yeah, maybe. Don't.
I'm gonna write you down.
Don't write me down because I can't. I don't have time, Dan.
Okay. All right, I won't write you down. Esther, do you want to make a cutting head? Less so. Okay. All right. Okay. Well, The other general team updates is that on Tuesday, we're going to have what's that called? It's going to be virtual engineering immersion. So you get to immerse yourself into your laptop and learn about all the things that you're going to be able to do next year. And hopefully this year as well. So it'd be good if people could come to that. Esther, it'll be from 5 to 6 p.m., so 1 a.m. your time. Not really sure if that's of interest to you. But it would be good if we had some, it'd be good if we had some Hyperloop members in the audience that, if things are kind of dead on Tuesday, can ask some pretty general questions that we could maybe kind of brainstorm prior to Tuesday.
Is the immersion going to be through Zoom?
It is. Actually, Dan, can I take over and talk a little bit about this?
Go for it. Yep.
Cool. Yes, it's over Zoom, and you need to. It's over Zoom, but it's like what we're in now is a Zoom meeting. All of the immersion things are Zoom webinars, so you can't just show up. You need to register to attend, and those registration links are now live. So they're on the UCEC webpage, UCEC, University of Colorado Engineering Council. Maybe Dan can link it.
Yep.
But yeah, we are in the Tuesday 5 p.m. session, which is the civil and mechanical groups session. And apart from having people there to ask questions if things are kind of quiet, they're raffling off a $75 Amazon gift card in every session, and there's a total of 7 sessions. So come to ours if you could. You might win a $75 gift card, and then if you want to up your chances of winning that gift card, go to the other sessions as well, because those will have their own gift card drawings associated with them. But do make sure that you register online for it.
What Cole said. So would anybody be free at 5 p.m.? Anybody interested for 5 p.m. Tuesday?
Tuesday? Yeah, I should be free.
Okay. Cool.
I should be
Dan,
available too.
Okay. Cool. So on Monday, we're going to go through the things that we kind of talked about, and then hopefully have parts on the way and maybe some first 3D prints sorted out. So yeah, thanks for coming. Going to try to keep meetings as short as possible and just get information in and out, and then that's it. So thanks for coming.
Cool.
If you want to stick around, I'll show off my video again.
I want to see it.
If you don't want to stick around, you're welcome to leave.
Yeah, I guess Esther won't see it, so yeah, okay. You can. Yes.
Oh, yes. All right. Let me get all set up here.
Are you gonna give us any sort of introduction, Cole?
Oh, to the video.
What is this video for?
Oh, sure. Okay. So it is engineering immersion related. Since it's, normally engineering immersion's in person, and so we would probably bring Ahmed and I would haul the tank down from East Campus back up to main campus. And we would all be out in, the Herbst Plaza or somewhere, and talking to potential students that are, interested in joining the team. This year, since it's virtual, there's no way to really do that. And so the way that they're running the webinar, or the immersion, like I said, was webinars. So they're having like Q&As and that sort of thing. But in order to get people excited about the webinars, and so that they know a little bit more about what is happening in the webinars and who's going to be in each session, all the orgs that are participating made like a 90-second-ish video that talks about their club. And the videos are getting released on like the CU Engineering YouTube stuff early next week. They'll be played at the beginning of the like immersion webinar, like all the immersion webinars will have the videos play first so that everyone can see them again. And yeah, just in general, it's sort of like a promo video for CU Hyperloop this year. So with that in mind, I'm going to start it. Unless
Do you want to
have
end the
questions.
recording first?
Yeah, go for it, Dan, if you don't mind.
Yeah. All right. Signing off, folks.